Hi everyone, welcome to my channel. My name is Fikrat. This video continues video series dedicated to learning Microsoft Fabric. In the last video, we started discussion around building real-time analytics system on top of ever-changing Lakehouse tables. So we use Spark structure streaming, change data feed, and time travel features to achieve that. And so we basically build a pipeline that would read from one table, apply certain transformations, and write into another table. Today we're going to go one step further and build remaining components of real-time analytics system. So we'll add near real-time reporting system, and we'll add smart monitoring and alerting system. Join me to learn more. So here is a quick preview of what I'm going to cover today. We'll start with the discussion of architectural components that are required for building real-time analytics systems. So we'll talk about components like data movement, transformations, reporting, and alerting. Then we'll bring design consideration discussion, which is important. So whenever you build real-time analytics system, you have to consider certain limitations of technologies. Next, we are going to discuss a couple of design options. First, I'll describe a solution based on predominantly Fabric components. Then we'll discuss about some other options that includes combination of Fabric and other Azure technologies. In a demo section, we'll first build near real-time reporting system on Lakehouse tables, and then we'll move on to build streaming pipeline for design option 1, which is based on predominantly Fabric components. A quick note before we proceed. This video heavily relies on the knowledge obtained in the last few videos. Namely, you need to have an understanding of Spark structure streaming, change data feed, and time travel. If you have not had a chance to watch my latest videos, I would encourage you to pause and do it now. I'll place links for this video in the description of this video. Let's get started. So what are the key architectural components of any real-time analytics system? First of all, you need to have data movement and ingestion pipeline in place, and that pipeline in many cases needs to be continuous and low latency. In many cases, you also apply data transformations as you ingest. Then you need to have automatically updated near real-time reporting system. Then ideally, you need to have smart alerting system that will react to certain conditions in your data. And finally, you need to take care of your actions. So actions can be as simple as sending notifications to certain people, but it can also be more complex actions like writing some data into databases, interacting with external systems, so on and so forth. So let's talk about some important design considerations. When building real-time analytics system, there are some system limitations that you need to take into consideration. First of all, you need to ensure that latency is low and satisfies your business needs. That means that you have to choose components that ensures continuous and low latency data movement. And you also need to try to minimize number of different components that involved in your end-to-end pipeline to reduce latency, because it's expected to have some latency when you have too many hops in your pipeline. And Another important consideration is the throughput of the components involved in your pipeline. Not all streaming technologies are capable of processing high throughput data. To give you an example, the data activator service that's part of Microsoft Fabric has a limitations of ingesting up to 2 events per second. That means that if you're trying to push high throughput data into a data activator, it will try to throttle and the service may become unresponsive. So what can you do to overcome these limitations? One of the common approaches on reducing data for real-time system is aggregating. So aggregating can be done on time-based windows, and by selecting size of your window, you can reduce your data significantly. Another popular approach is to use filtering. Filtering allows you to exclude all the unnecessary events. Filtering also would allow you to split your stream into multiple streams and process them separately. So let's talk about architectural options. One of the obvious architectural options for building real-time analytics on top of Fabric lakehouses is described on this diagram. So let me walk you through this diagram. So you have one lake hub, which is basically a lake house. From here, you can read, change, and stream your data using Spark structure streaming. You can also apply transformations as you stream. Spark structure streaming allows you to apply many different transformations that are available as part of PySpark language. So that means that you can apply aggregations, filters. You can bring lookup table to join to your data and enrich it, and so on and so forth. And once you have enriched your data, there are multiple options. So you can either stream your data to another Lakehouse table, which we did in the previous video, and then build near real-time reporting on top of that. Alternatively, you can also use event streams to push this data to further processing systems. Event stream has multiple input options. One of them is custom application source that allows you to build event hub type of endpoints to receive data. So basically from Spark structure streaming, you can send your data to event hub endpoint, which will be source for event streams. And from event streams, you can write into different systems, including Lakehouse, KQL database. Once you write your data into KQL database, you can also have further transformations on top of that and consume it from near real-time reporting system. Alternatively, you can also write output of your event streams to Data Activator. So Data Activator is a great monitoring and alerting system. It allows you to see your streaming data real time and set up alerts based on certain conditions. It also allows you to define actions. And actions can be as simple as sending notifications, but you can also create custom actions which will use Power Automate flows. And with Power Automate flows, you can essentially do lots of different actions, including interacting with different systems, writing into databases, and so on and so forth. So this design option will cover almost all your real-time analytics needs, including near real-time reporting, alerting, actions, and so on and so forth. However, you need to ensure that your streaming throughput does not exceed Data Activator's maximum limit. Now let's talk about alternative approach. With this approach, you are pushing your output of your structured streaming to Event Hub. So Event Hub is a separate Azure service designed to handle high throughput streaming data. It's very scalable. Once you have data in Event Hubs, you have multiple Azure services that can consume this. I have provided few options here, but this list is not comprehensive. So first of all, you can push this data to Azure Streaming Analytics service, which allows you to apply transformations. This is another high throughput scalable service. The beauty of this option is that you can actually apply your transformations using SQL-like language. And once you have a data in Azure Streaming Analytics, you can push the data to many different destinations. So Azure Streaming Analytics has lots of connectors. I just provided here few destinations like Cosmos DB and Power BI, but you can also write into SQL database, some other databases. Alternatively, you can also use logic apps to process your data. It's another Azure service which is also very scalable. With this, you can handle different actions like sending email notifications, team notifications, but you can also apply many different kinds of transformations. You can write into databases, you can trigger stored procedure, and so on and so forth. Now that we have covered architectural considerations of building real-time analytics systems, let's move on to the demo sections where we'll first build the real-time reporting system, and then we'll build pipeline which covers option 1, which involves predominantly Fabric related components. Alright, I am in Microsoft Fabric and I navigated to one of the existing lakehouses. For the purpose of this demo, you will need to have two artifacts, the data file and the PySpark notebook that you can see on the screen. You will find both artifacts in the description of this video, so please upload the data file into unmanaged section of your Lakehouse. Take its path and place it inside the load command here. This notebook has two logical sections. In the first section, I am creating streaming pipeline to transfer data from one table to another table within the Lakehouse. And that part is very similar to what we have explored in the previous video. There are some slight change which I'm going to explain as I walk you through cells, but otherwise it's similar. So my plan is to run this streaming pipeline and then create near real-time reporting on top of destination table. In the second section of this demo, I'm going to create streaming pipelines that will read from the same source table and write into event stream and smart monitoring and alerting system. I have provided a detailed explanation of most of the commands in the first section, so I'm not going to spend too much time on that. Please take a look at the previous video. Instead, I'll walk you through high level on what's going on here. So my first command reads the data from the data file and creates stocks table based on that. So this is stock exchange play data. Within this demo, I'm going to use few columns here. The time column, which represents event timestamps. and then I will use symbol column alongside with sequence column, which is somewhere here. So I will treat these two columns as primary keys, and then I will be manipulating bit price column to imitate update transaction on the source table. So if I scroll down, I'm creating lookup table here, which will be joined against stocks table. And here I apply certain transformations to existing data in stocks and write them into destination stocks process table. So this command takes care of historical data. Small change I made here, I changed data types for bit price and timestamp because I realized that they were string in the destination. So if I scroll down, my next command enables change data feed on the stocks table. And if I scroll down on the streaming CDF section, I have two important commands to create streaming pipeline itself. So this command is parent streaming pipeline. It uses read stream and the write stream here. And as a destination, I am using for each batch method. And the reason I am using for each batch method is that I intend to use merge into logic, and you cannot use merge into logic by using standard streaming API transformations. However, using for each batch method allows me to include static data frame transformation within this function, which in turn allows me to use merging logic, as you can see here. Besides merge logic, I also have deduplication logic, which is important part because merge logic, as you may know, will not work if you have duplicates in your source and destination. All right, so let me run all these commands above command 44. So that will create a streaming pipeline. And while my streaming is getting started, I will walk you through a few other commands down the road. So here I have a Python function which will imitate continuous update transactions on the source table. So basically I have while loop here where I apply update transformation and then wait a few seconds. So duration of this wait can be configured. So this is just one of the parameters to this function. And then this command basically calls this and says wait 1 second between transactions. All right, now that we have streaming transaction up and running, let me run this pipeline to imitate continuous transformations. And now I can start building reporting on my destination table. All right, let me navigate to my workspace in another tab and find the Lakehouse that I have created tables in. So this is my Lakehouse. I'm gonna choose SQL Analytics endpoint and then use new report button to create new Power BI report. Next, I'm gonna create line chart, which I think is best for time series data. I'll find stock process table and bring sequence and the time in the x-axis. And we'll bring bit price on the y-axis. So that brings me a nice chart, and I'm gonna add filtering here to filter out symbols. So let me select one of the symbols. Next, I'm going to change my aggregation type to average because summarizing bid price doesn't make sense. Next, I'm going to apply filtering on time column because it makes sense to focus on most recent section of your data. In most cases, I'm going to use relative time filtering and put 1 hour limit. Finally, I'm going to change refresh settings of this report so that it would auto-update with certain frequency. So I'm going to open Format tab, open Expand Page Refresh tab, turn on button, and with that, now I can specify refresh frequency. So I'll set 15 seconds frequency, and I'll save my report. So with that, I'm going to wrap up the first part of the demo. I'll come back to my notebook and cancel my transaction pipeline, and then I'll stop my stream. In the second part of the demo, I'm going to create a streaming pipeline that will push the change data feed to event stream, and from there data will go to data activator. To achieve that, I'll need to install Event Hub related libraries because I'm going to use Event Hub endpoint of event stream. So you'll need to run this command to install Azure Event Hub libraries. Then I'll import certain libraries. I'll also run describe history command to understand what's my last table version. So that's 31. I'm going to change start version so that my stream starts from that point. My next command is Python function that generates streaming going to Event Hub destination. So this line number 17 indicates that my destination is going to be Event Hub, and for Event Hub configuration, I'm using this variable parameter, which is passed to this function as a parameter. Some other differences here. As you can see, I have group by method here, which includes a unique column as well as timing window. So this timing window creates 60 seconds long window triggered at each 60 seconds. Another important part of this transformation is watermarking clause, which tells to wait 10 seconds for any late arriving events. So that's important because, as I mentioned in structured streaming video, when you aggregate data by time window, it's important to account for any late arriving events. So in this case, I am allowing 10 seconds grace period. And finally, I am using average method to calculate average of bid price during this window. Before I generate this stream, I'll need to have Event Hub endpoint. So for that, I'll need to create event stream. I already created my event stream, and you can create it from create command. So if you need to learn more about that, I have a number of videos on this topic. For now, I'll just walk you through the design of this event stream. So this event stream is very simple. It has custom application source and reflex output. So reflex means that the data goes to data activator service. So let me show you a configuration for custom application data source. Here I selected Event Hub tab, and if I select Keys tab here, I will see connection string primary key setting, which I can copy and paste to my notebook. So my next command here requires connection string for Event Hub. So once you create your event string, please copy paste your Event Hub's endpoint here, and then we run this command. Next command is optional. It's only needed if you want to clean up the previous run's checkpoint. My next command generates the stream, calling the Python function I just described, and it passes the variables that we have just configured here. Let me run this, and that will assign streaming handle to this variable. Now that I have streams handle, I can inquire the status. So processing new data means that data is already going to event stream. And if I click here and refresh, I should be able to see new data. All right, now that we have configured the input, let's talk about output. So reflex output configuration is straightforward. If I hit this edit button, you will see that I have named my reflex item as stocks RFX. All right, after a few minutes, I can see the data showing up on my reflex output. One thing I forgot to mention that you need to generate transaction so that, because remember this structure streaming is based on change data feed. So for that reason, I will need to call this function that we already discussed. And with that, my pipeline works fine. Now I can navigate to reflex items that I have created here. So I can already see data coming to my reflex item. Let me change my window to last 1 hour. And here I have created few properties. Just to remind you, properties are the signals that you want to monitor. So in this case, I have average bid price. I also included window end and start date, which are part of the data, as you can see here. So this window indicates aggregate windows that I described earlier. Besides properties, I also created trigger. So let's take a look at its design. So this trigger monitors average bid price signal. So let's see what are my values. So my values are between 1 and 10. In the next panel, I can set the trigger condition. Here I'm saying trigger some actions when the average price becomes less than 2. And in addition, I have set a filter here, which will monitor for one specific stock exchange symbol. So I can already see some instances of this trigger. Next, I'm gonna define actions. I can choose between standard actions like send email or send message to Teams. But I can also define custom actions using Power Automate, which will allow you to do a lot more. If you are interested to learn more about Data Activator, please take a look at related video in my channel. For now, though, I'll just wrap up the configurations. The only thing I need is to include average bid price information in my alert so that whenever I receive notification, I know which value triggers this alert. I'm gonna save my configuration. That concludes our discussion. To recap, we have created near real-time reporting on top of streaming destination table. And then we have created end-to-end pipelines that will deliver change data feed from Lakehouse tables to event stream and the data activator from there. And finally, we have identified our monitoring conditions, alerts, and actions. I hope this video was helpful. Thanks for watching, and I will see you in future videos.